We are live. Take out your red writing utensil. Have us ready. Leave us checking some answers. We're looking at page 103. There's homework 3B, 3 through 30 multiples of 3. Here we go. Number 3. There are two intervals. X belongs to, I'll do X belongs to in all of these, this is interval notation. So X belongs to round bracket 1, comma 2, round bracket. Does that make sense? And then the other one is X belongs to round bracket 4, comma infinity. Can I repeat some of that? Okay. Number 6. There's only one interval. X belongs to round bracket -3, comma -2, round bracket. Number 9. X belongs to round bracket -infinity, comma -1, square bracket. And then the other one is X belongs to square bracket 3/2, or 1.5 if you're addicted to decimals, comma infinity, round bracket. Any repeats so far? All right, number 12. This one, there's only one solution. X equals 4. If you want to be fancy and do interval notation, you do X belongs to square bracket 4, comma 4, square bracket, but that's kind of a math joke. Just go from 4 to 4 and include 4. So it means 4. Moving on. Number 15. A belongs to, they keep changing the letters too, which is annoying. A belongs to round bracket 2, comma infinity, round bracket. Number 18. There's an equals in there again. Y equals -1. That only happens when it bounces on the x-axis, where it just goes 0 just for an instant. If you didn't catch that, don't stress too much, but I will cover it today. So first of all, y equals -1, and then the other interval is y belongs to square bracket 1/2, comma infinity, round bracket. And it repeats up to number 18. Number 21. Y belongs to round bracket -2, comma 2, round bracket. 24. Y belongs to, there's two intervals here. Round bracket, -infinity. Gentlemen, if you're chit-chatting, you are not checking your work. I can pretty much deduce that from the get-go. Again, number 24. Y belongs to round bracket -infinity, comma -3, round bracket. And the other interval is y belongs to round bracket 1, comma 3/2, round bracket. And it repeats on 24. 27. Let me see. Two intervals. X belongs to round bracket -4, comma 5/2, square bracket. And then the other interval is X belongs to round bracket 7, comma infinity, round bracket. And last but not least, number 30. N belongs to round bracket -infinity, comma -4, round bracket. And the other interval is N belongs to round bracket 0, comma infinity, round bracket. Any interval? Any repeats on any of those whatsoever? So 30, yeah. Two intervals. From -infinity to -4, round brackets on both. And from 0 to infinity, round brackets on both. Any others? I'm going to grab my water. Any others? Going once. Going twice. This is for repeats. We're going to go through the questions, yeah. Last call?
Wait, what was number 6?
I'll tell you in a second. Number 6 was, my voice just bounces off the back wall when I take the mask off. Number 6 is one interval. X belongs to from -3 to -2, round brackets involved. Alrighty, questions? Any of those you wouldn't be prepared doing on a test? Go.
Here's number 18.
18, yeah. Can you read it up for me?
Oh, 2y, wait, I don't know if I heard that. Okay, 2y cubed
Okay.
plus 3y squared
Uh-huh.
minus 1 is greater than or equal to 0.
Alright. So this one, again, the fact that they're using y, you could actually substitute x if you wanted to, if it makes you feel better. It really doesn't make any difference. Now, can I factor this? Short answer is there's no basic math factoring method, because you can't factor by grouping, there's 3 terms. Can't even use a quadratic formula because it's a cubed. Can't magic pair because it's a cubed. Looks like we're stuck. We have to use a good old-fashioned guessing. The rational roots are the only ones you would have to guess. And it's the factors of the last over factors of the first. So it's plus or minus 1 over plus or minus 1 and 2. The only roots you're going to get are 1, -1, 1/2, -1/2. Those are the only possible nice roots this thing has. If none of these 4 work, you're off the hook from even doing the problem. Because there's no, if it's that icky, then nobody's going to blame you for just giving up. So far. So for now, take your pick. What do you want to try? 1? Sure. Be careful when you're doing synthetic division. Do you see a missing term? Give me the coefficients. 2, 3, 0, -1. Correct. This is plus 0y. There's a missing term there. If you don't put that in, synthetic division will give you the wrong answer. Let's try it. Add. I don't know. Oh, I go for it. Add. Multiply. Add. Multiply. Add. Multiply. Add. Did it work? Unfortunately, no. Try another. Sure. -1. Sounds good. So I'm going to do the 2, 3, 0, -1. Go for it.
So 2,
Uh-huh.
-2,
All right.
1,
Uh-huh.
-1,
Uh-huh.
-1,
Mhm.
and then 1.
Does that work? Yes, you just found a root. Congratulations. And this, can somebody translate this for me? This used to be 2y cubed. What is it now? Oh, not x. There. Wow. So what is it now? B, take over. 2y squared plus 1y plus plain old -1. This is small enough that you can try magic pair, or you can just try the quadratic formula. Take your pick. Jack Love, take your pick. That might factor, I don't know.
Do you say magic pair? Let's do that.
Hypothetically. Let's try it. So 2y squared plus 1y plus -1. How do you do magic pair?
Multiply the first and the last term,
Alright, what do you get?
-2y squared.
Okay. Can you think about multiplied pair that adds up to +1?
-1 and 2.
Yeah, 2y times -1y. That should work. Plug that in for here and tell me what you get.
2y squared plus 2y,
Uh-huh.
minus 1y minus 1.
I know they grab the opposite, but go ahead.
And you can group and take out 2y,
Yeah.
and you get y plus 1.
Good.
And then you can take out -1,
Uh-huh.
and you get y plus 1.
Is this gonna work?
Yep.
Yes. Pull out, and you get y plus 1, and then 2y plus -1. Now remember, this is set equal to what? In order to get a root.
Oh, 0.
Yeah, to get a root, otherwise known as a solution, set equal to 0. So finish it off for me. What do you get here?
-1,
Y equals -1.
and then you get
This is 2y minus 1, if that helps.
Yeah, you get, 1/2.
Yeah, you get y equals 1/2. Which interestingly enough, what does that mean? I already had y equals -1.
Double root.
That's a double root. So there are 3 roots here. You've got y equals -1, y equals -1, and y equals 1/2. Good. So if you run a plus minus notation, the only breakpoints we have are -1 and 1/2. And just make sure you do -1 as a double root, and then 1/2 as a single root. So, what number do you want to test? John, take over.
0.
0 sounds lovely. If x, I hate it when they do the x's and the y's. Fine, okay, y is equal to 0, and then what's the answer? It's, here's the original thing. You don't have to do the fact that thing unless you want to.
So it's negative, isn't it?
Yeah, it's going to be 0, 0, minus 1. Negative. I need your focus up here. So what's this?
New stuff?
Please.
Pop it.
Why do you say that? You're right.
Because it's a single root, so it switches.
Correct. What about here?
It's still negative.
It's still negative. Michael, why?
Because it's a double root.
What does that mean?
It just keeps the change.
How come?
Whatever, it keeps the sign the same.
Yeah, why?
Because it's like flipping a light switch.
Very good. Nice, good save. Stay with me, y'all. So, negative, negative, positive. Which regions do I want? Sophie?
Positive.
I want the positive regions. I want everything here. So that's this. And what interval does that give you? Y belongs to what?
1/2, comma, square bracket 1/2,
Correct.
comma, infinity, round bracket.
Correct. Why square bracket on 1/2?
Because it's a root.
It's a root. That means it's safe. There's one other reason.
And there's an equal sign.
Yeah, they want it. If there's an equal sign, they're asking for the boundaries, but only give them the boundary if it's safe. So, does that make sense? Okay, which one is that again? Number 18? Alrighty. Oh yes, there was an extra thingy. Did anybody catch it? I don't blame you for not catching it. If this is all you put, I would have expected that. If you graph this thing, like, if you kind of graph this, it would kind of sort of look like this. Do you see negative means it's below? It'll be below, 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 hits at -1. And then it goes back down. And then it's going to go up and hit at 1/2. Where is this graph above or equal to 0? Here's the above portion that you found, 1/2 and beyond. Do you see one other place? -1. It is exactly equal right here. The equal caught that point. Just barely. That's rare, but it does happen every once in a while. Does that make sense? Okay, it's a little weird. That's not even an interval. Well, it's a stupid interval. From -1 to -1. It's basically, you could put y equals -1 and I'd be totally fine with that. But do you see why the -1 actually qualified as being a good answer? They want everything on 0 or above 0, and there's a teeny little point that actually qualifies, sort of by random chance. Okay. So if you have a bounce, you might, like if this were just less than or greater than, you wouldn't have to worry about that. They just want everything solidly below. But this actually caught that mystery point. Next. Yeah. 21. Yeah. Read it off. Let me wake some stuff up. But I'll have you read it off for me in just a second. Okay. And we have number 21 in front of them?
I think so.
Okay.
If somebody wants to look to return the array, y is in 4, so it's y is less than 4, and this is y plus 4 minus 4.
Like that?
I think so.
Okay. Let me double check. 20. Yeah, you're correct. What do you do first? Jack, take over. you've got to get the answer down to 0. To solve anything with multiple species of x or y or whatever, you've got to get the answer down to 0, even if it's inequalities. I'm going to subtract 16 and subtract 4y on both sides. Tell me what you get. Keep going.
So you get, well, y to the fourth plus y to the third, and then just to get it out of the way right now, you can put, well, I put plus 0y squared, just.
Okay. That's clever. Okay, go ahead. Plus what?
0y squared.
0y squared.
4y minus 16.
Plus negative 4y plus negative 16 is what?
Less than 0.
Less than 0. I'm going to put a 1 here, a 1 here, a 0 here, a negative 4 here, negative 4 here. Everybody right so far? Alrighty, nice. What do you do with it?
You can do synthetic division.
Yeah, there's no standard way to factor this. It's got 5 terms and it's huge. So we just got to start guessing. What would you recommend we guess?
Negative 2.
Really? Okay. Now, by the way, I would guess with 1 and negative 1 and they would both fail. Okay, negative, I'll play along with it. Negative 2. Just randomly picking negative 2 out of thin air.
Actually,
So-
I guess that.
So 1, what? Are you serious?
Well, yeah, I just looked at the numbers and was like 1 and negative 1 aren't gonna work, so.
Oh, okay. So run it for me. Jill, we're just trying negative 2 to see if it works. 1.
Negative 2,
Uh-huh.
negative 1.
Okay.
I'm getting splashed.
2,
2, fix it.
2,
Uh-huh.
negative 1,
Uh-huh.
0.
Please combine now.
Negative 8,
Good.
and 16, 0.
0. Congratulations. Ta-da. Now, we've got, this is y. So we've got a root at negative 2. Noah, give me another one.
Another one I had was 2.
2. Just off the top of your head. Go ahead and run it for me.
So 0 and then 1.
Second.
Like,
Oh, I see.
yeah,
So, yeah, 1.
1, then 2,
Okay.
and then 1,
Okay.
and then 2,
Uh-huh.
then 4,
Uh-huh.
then 8, and then 0.
And 0. Sure enough. We've got 2 roots already. How many are left? Pete, take over. How many roots are left? 2. This was y to the 4th. It went down to y to the 3rd, and now it's y squared. How do you find these? It's a quadratic now. It's small enough that you can use what? If you get desperate. Quadratic formula. Let's do it. I normally do x equals. They messed with us, so it's y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Do it for me, John.
So negative 1 plus or minus 1 minus 16 all over 2.
Notice anything suspicious?
It's going to be a negative square root.
Yeah, what does that mean?
It'll be imaginary.
They're imaginary. What does that mean for our plus minus notation? Yeah,
You just ignore them.
you can ignore them. It's an imaginary root, so you don't even have to worry about it. So the only roots you actually have to plot, it's good to check. Don't just ignore these from the get-go. You have to make sure they're imaginary. So if they're imaginary, you don't have to put them on the graph. The only 2 roots we did have are 2 and negative 2. Single root, single root. And then there are 2 imaginaries somewhere. Test these. I'm going to try 0. Question, math people. Actually, go ahead. If you plug in a 0 into this mess, what would you get?
Negative 16.
Negative 16. So is the region positive or negative?
Negative.
Correct. How about this region?
Positive.
How about this region?
Positive.
Correct. What do we want? Positives or negatives?
Negative.
We want the negatives. And there's only one region that fits the bill. Give me the final answer.
X equals,
I wish it were.
or sorry,
Y
y
belongs to.
equals, round bracket,
Huh?
-2, round, sorry, 2, round bracket.
Got it. That's it. The thing that made that annoying was there were two imaginary roots. But once you realize they're imaginary, you don't even have to find them, you just ignore them. Okay. That's a good life lesson, by the way. If the thing that's chasing you and threatening to kill you is imaginary, you don't have to run from it anymore. Just saying. So, next. Any other ones? Mm-hmm.
Delete 30.
Yeah, sorry? Yeah. Number 30. I shouldn't speed through my water. That's a fraction. So it means for the first time ever, we're gonna get some, either asymptotes or poles, depending on if anything cancels. Let me look. They changed it to n. I think this must have used them to torture people. So n squared plus 4n plus 4 all over n squared plus 4n. And the condition is greater than 0. So everybody see, by the way, when you just have greater than without an equals, you'll never have any square brackets in your answer. Can somebody tear this apart for me? Michael, go.
Wait, I have a question.
Yeah, I have a question too. Answer mine first.
Whoa, Mr. Johnson, that was thick. That was
I
part
am
of the video.
teasing. I am teasing.
I know.
Go ahead.
Well, it's,
How about the bottom? Go for that.
I'm teasing,
well,
but
the
yeah,
top
like-
one's spoiled.
I'm serious, but in a teasing sort of way. Go ahead.
The top one you can put n plus 2, and then, the other one n plus 2.
Yeah. Okay, what about the bottom? That's easier than that.
Oh, do you have to put a 0 at the end?
You do not. You could, but it's way longer. Yeah.
Just pull out the end.
There's a GCF. There's an n. And then n plus 4. Are there any holes in this thing? Oh, math people. No, there's nothing that cancels. So how many objects and what type? Sophie, take over. What sort of objects and what kind?
Is it a double root at -2?
Very good. There's a double root at n equals -2. And what else?
And a vertical asymptote at -4.
Okay. Negative what?
4.
-4, and there's one other. A little harder to see. Yeah.
So,
At n equals 0. See that one here? It's kind of like n equals 0, or n minus 0. So, plus minus it. Dylan, no, take over. Mark them. What do I need to mark? Oh, sorry.
you want me to put them on the graph?
Please. And I'll answer your question in just a second. I have not forgotten.
So do 0, or we can start with -4.
-4,
-2.
-2,
0.
0. What do I put at -4?
Dots.
Yeah,
Line dot things, yep, that. And then a line at there, right? Yeah, well, like a dot and then a line like going up,
Oh, I see what you're saying. And what kind of a root is this?
double,
Yeah, we mark it as double. And then,
same thing for
yeah, correct. Vertical asymptote thing. So, let me see, take over Polly. What would you like to test?
Can you do -1?
Sure, -1 sounds good. So n equals -1. Plug that in to the original formula.
It's the wrong
It's
one.
the,
Which, oh my God. There, that fixes everything. Go ahead.
So it's gonna be 1 squared,
Okay. So 1 squared, -1 squared.
-4,
4 times -1. Yeah, -4 plus 4 all over.
-1 squared,
Uh-huh.
plus
Good. So this is going to be 1 plus -4 plus 4 over 1 plus -4. Calculate.
that's gonna be 1
Okay, over
over,
-3. So is it positive or negative?
negative.
Negative. This region is negative. How about if you hop over this asymptote, or, yeah,
It changes.
correct, because it's a single asymptote. How about here?
No,
Correct, because it's,
the double.
the double root doesn't change, or changes twice. How about here?
Yeah.
Yes. And what do they want, positive or negative? They want positives. So I want this, and I want this. Give me the final intervals.
So you have, say, n belongs to,
Uh-huh.
round bracket,
Uh-huh.
negative infinity,
Good,
almost negative 4,
good.
and then
Round or square?
you lose a round,
Round, how come?
because it's just a less than each round of the side.
True, and there's another reason.
Oh, yeah.
It's a vertical asymptote, and if you touch it, you die. Go ahead.
How did you do the, like the testing point?
Oh, I plugged n equals -1 into the original formula. And I get this.
Don't we?
Oh, sorry, wrong, sorry, pointed the wrong thing. I had to put it in here.
Why can't we do that?
You can do it in here too.
Oh.
They'll give you the same answer either way.
What about like the parentheses? And I usually do like,
Yeah, this would be,
bracket,
that's the factored version.
and then I just would do
Then this would have been like,
positive,
it would have been positive,
positive,
positive, negative,
positive.
positive, yeah,
So we can do that too.
correct.
Okay.
Yeah, if you use this one, just do it by hand. If you do this one, you can do the pluses, minuses. And I'm sorry, where was I? Finish it off for me.
Okay, then we have -2, right?
I was looking for positive intervals.
We're doing negative.
Those are negative intervals. I'm looking for positives.
Oh, sorry.
So you got this interval,
Um,
and there's one
maybe
other interval.
0,
Yeah, from 0 to
infinity.
infinity,
Yeah, both.
both round bracket. Okay. Michael, question, and then Sophie, question.
What?
You had a question?
Oh, yeah. I know you can't, well, I guess I don't know why you can't do this, but why can't you just like cross out n squared, and 4n, and 4n?
These,
Yeah.
because of the plus sign.
Oh.
If they're separated by a plus sign, the short answer is, what does this bar mean?
Divide.
Division. What does division cancel?
Oh, multiplication.
Right. If it were n squared times 4n over n squared times 4n, you could do it. That would work. Because division cancels multiplication, but it does not cancel addition. So unfortunately, you can't. It would be lovely if we could, but you get the wrong answer. So big question.
I can do that.
Okay, nice. Anybody else? Yeah,
Could you number, 27?
27. Sure.
Wait, what number was that?
30. And let me erase. And does somebody have 27 that could read off for me? Hang on a second. Let me clear off some space. And then, go for it.
2x minus 5
Huh?
cubed,
Oh, like that?
yes,
Wow, okay.
over x squared minus 3x
Uh-huh,
minus 28
uh-huh.
is greater than or equal to 0.
Good. Believe it or not, even though this looks horrendous, they were very nice to you. The top is already factored. What do you find on top? What sort of creatures? John? Like-
The roots? Is
Roots,
that what you're after?
correct.
Yeah. So it'd be 5 over 2,
X equals 5 over 2. What kind of a root is it?
it's a triple root.
It's a triple root, because it's 3 of them in a row. Does that kind of make sense? Do you follow that? Can somebody attack the bottom for me? Pete, help me out here. Is the bottom factor?
Yeah,
Go for it.
well, could you do x plus 7x minus 4?
You're very close.
X plus 4x minus 7?
Yeah. X plus 4x minus 7. Those will add up to -3. Other way around would have been +3. Good. So what two creatures does that give you?
Vertical asymptotes.
Yeah. So vertical asymptotes where?
-4 and 7.
Yeah, x equals -4, x equals 7. That sure not doing too bad. So, I'll just mark these really quickly. -4 is your first, and that's a vertical asymptote. 5/2, which is like 2.5, which is a triple root. And 7th, which is a vertical asymptote. Can somebody finish this for me? How would you do this problem? Michael, take over.
So, plug in the 0.
Sure, as long as 0 is an option, that would be this region, right? So if x is equal to 0, so what's y?
Oh,
Go ahead and use this. You can use the factored version if you want. Plug in a 0 here and tell me what you get.
well, it's a negative,
Yeah, it's negative cubed.
oh,
And then the bottom?
positive, negative,
Positive, negative.
so positive.
Why do you say positive? Yes.
There's 2 negatives.
Actually, there are
Well, 4 negatives.
4 negatives. Good. Does that make sense? This is negative, 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 negative. It's positive. So this is a positive region. What about over a triple root? Does this change?
Yeah,
It does. How about over a single asymptote?
yeah,
Yes. Single asymptote?
yeah,
And what are they asking for?
positive.
Positive regions. So here and here. Are they going to want the endpoints?
Yes.
Yes. Only give them the endpoints if they're safe, by the way. Go ahead and finish it off. Grand finale.
Or it's all round brackets, so negative.
Will?
Oh,
Well, you
except
definitely go to -4.
Except for 5 and
Ah. Why is -4 a round bracket?
because of the vertical asymptote.
Yeah, and don't touch unless you die. Think of Genesis chapter 1 or 2. No, it's 3, whatever. I don't know, I'll look it up. You shall not touch you shall not eat the tree of life lest you die. Die to death. Anyway, go ahead.
Is a square.
Square bracket, correct. And then
And then it's 7
7 to
infinity.
infinity. Round bracket, square bracket?
Round.
Round for both. 7 because it's deadly, and infinity because you can't touch it. Yeah. Does that make sense? You think you might be able to do that on a test? I mean, you sort of already did, but you get a chance to do it again. The questions. Alrighty. Yeah, go on,
Can
sorry,
we
go ahead.
go over number 24, please?
24, yeah. Can you read it out?
Yeah.
Okay, let me read some space. All right, go for it.
2y cubed
Uh-huh,
plus y squared minus 12y plus 9 is less than 0.
all right. Notice the less than, there are going to be no square brackets. Can I factor this thing by normal methods?
No.
No, it's tempting to look at factor by grouping, but if you try, it doesn't work. The parentheses don't match. If this pair and this pair are not proportional, you don't have to do it. Yeah.
So, yeah, I guess I had a question about that, because if y does grouping work sometimes, and sometimes it doesn't.
Oh, I'll give you an example of when it does. I'm just going to make this up off the top of my head. 5x cubed plus 7x squared plus 10x plus 14. I guarantee you this will work. Tell me why.
I mean, because they're proportional.
Yeah,
Right,
5
but-
goes to 7 is 10 goes to 14. Or another way of thinking of it, 5 over 10, 7 over 14. They both match.
Okay. So it's kind of just luck of the draw?
If you're lucky enough for these to be proportional, it's guaranteed to work.
Okay.
If they're not proportional,
There's no
it will
way.
never work.
Science, yeah.
Correct.
Um,
Right. This would have to be like 2, 1, -12, -6, and that would have worked perfectly.
Wait, I'm confused how these are connected.
Oh, these. I want to see 5 goes to 7. There's 2 ways to do proportions.
Where'd you put those new numbers?
Oh, these I just made up off the top.
Oh, okay.
Oh, sorry.
Like,
Yeah.
I'm confused. I guess I should have known you.
This is just random. I'm sorry, I should have done this. You see how these are proportional? They're pretty much the same fraction. Reduce that, that's 5 7. Same thing here. You can do first and first, second, second. As long as they're proportional, it should work. If they're not, then
No, it's not.
this one is not, unfortunately. The one thing is that, like, if you go from here to here, just look at the numbers, it's half as big. It would have to be half as big here too. This would have to be -6, and it's not. So, you could do the, yeah. So what's the only method we can use?
Synthetic.
Guessing in synthetic division, right? What would you like to try?
1.
1. I think that's good. So it's 2, 1, -12, 9. I'm gonna turbo this, so add, multiply, add, multiply, add, multiply. Yippee! Whoever picked 1, bravo. So,
lucky.
yeah, I know, so insanely lucky. This is 2y cubed, what is it now? 2y squared plus 3y plus -9. If it gets down that small, I would suggest just pull out your quadratic formula and finish the thing off, put it out of its misery. So I'm gonna do y equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. So y equals -3 plus or minus the square root of 9. Notice the minus minus plus. 8 times 9 is 72. That's actually going to come out pretty well, gentlemen. This is square root of 81. What is that? It's 9. So it's going to be -3 plus or minus 9 over 4. So you get two solutions. -3 plus 9 is 6 over 4. -3 minus 9 is -12 over 4. So you get 3 halves, and you get -3. So you got 3 roots. We've got y equals 1, which you would insanely like to get. Y is equal to 5/7. What the heck am I? Oh, no, that was the proportion thing. I fooled myself. Y is equal to 3 halves, and then y is equal to -3. Do plus minus notation. -3 is the smallest. And then 1. And then 3 halves, which is 1/2. All of them are single roots. I'm going to try 0. You might as well not even factor that. Tell me what you get if you plug in 0. Positive 9, which is just positive. These will switch, so negative, positive, negative. It's looking for negative regions, so this and this. So it's a y belongs to -infinity to -3, round bracket, and y belongs to 1, 3 halves, round bracket.
So, I guess I have a question. When I was looking at the homework, I wasn't even thinking of, like, doing synthetic division. Do we just use that when there's nothing else that we can do?
It is, yes. It is a method of sort of last resort.
Okay.
If it doesn't factor, that's our main tool. Well, if it doesn't factor and if we can't do quadratic formula,
Okay.
this is our second to last resort.
Okay.
Then our absolute last resort is guessing and checking with synthetic division.
And are we ever getting back to, like, actual graphs?
Yes, as a matter of fact, funny you should say that. It's the next assignment. You may also be looking at the clock and saying, how fast can Mr. Coughlin possibly do this? Not that fast. So you do not have homework tonight.
Don't get used to it.
No, you do. One thing I am going to show you is this. I will also say that I'm going to be relatively casual in some of the graphs. The points that you get are going to be the, well, let me show you. See this, I'm going to just pretend y equals 2x cubed plus 1x squared plus -12x plus 9. And I'm going to change this to less than, yeah, let's plan on less than. And I want you to graph it. Go ahead and write this down. This is the last problem I'm going to give you. It's the only problem I'm going to give you. The reason I chose this, and I see something familiar on the board. Yeah, it's identical to this. Any reason why I did that?
Because you know it works.
Mm-hmm. And we already know the answer. What are the 3 roots that we got? I'll just use x equals for this one. What's the first one we got? x equals 1, and then x equals 3 halves, and then x equals negative 3. Okay. If you graph this thing, quick question, what's another word for root? Yeah, x-intercepts. That will come in handy. These are x-intercepts. There are 3 of them. Put them on the x-axis. However, do you see this? Where I'm pointing? What kind of dots are we going to use? Open dots. Correct. Put an open dot at 1. Put an open dot, this is 2, I'm just going to put it at 1.5. And put an open dot at negative 3. Now we're still not sure what this graph is doing. Tomorrow I'm going to give you something of a crash course in what polynomials look like if I give you something with power 3, something with power 4, something with power 5. By the end of tomorrow, you'll be able to graph something with x to the 10th power. They're actually kind of impressive. And they're easier than you think. Actually, way easier than you think. But for now, this is negative 3. This is 1, this is 3 halves. Can somebody tell me the y-intercept? This is kind of an oddball question out of the blue. How do you find a y-intercept? Take chubby hand at it, go.
So equal to 0.
So what equals 0?
X.
X equals 0.
So would it be 9?
Correct. 9. I'm going to do that. That'll be an open dot as well. Can anybody predict where this graph is coming from? And where it's going? Yeah.
It looks like it's coming from below.
Looks like it's coming from below. Does that make sense because it's aiming up here?
Yeah.
And where's it going to go from there?
Down.
Down and then
Back up.
and then immediately back up. There's another thing that would tell you. Minus means it's below. Plus means it's above. Minus means it's below. Plus means it's above. There's this teeny weeny little spot where it's below. It's going to do this. And by the way, use a dotted graph. Now, by the way, I do not know if this is the maximum. It probably is not. Do you notice there's a space from negative 3 to 1? Where's halfway in between? A minute. What's halfway in between these two roots? Negative 1. That's probably pretty close to where the max is going to be. So it's probably going to overshoot, and then this is going to be on its way down. Does that make sense? And then it's going to take a teeny little detour and go back up. There's only one last thing to do. Shade. You remember shading lines? How do you find out which way to shade? It's the exact same rule.
I'm gonna point.
Test a point. What's a good easy point to test?
0.
0, comma,
Yeah.
0. Plug in a 0 for y and a 0 for x. 0 is less than 0 plus 0 minus 0 plus 9. It's basically a saying 0 is less than 9. True or false? That's true. Where do you shade? Above this mess or below this mess? Below. It looks like this. Congratulations, you did a fairly involved graph. We'll pick up that more tomorrow. Please stand. Oremos. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Good to go.
Thank you.
Thank you. And a good evening. Stay warm. And I can hit stop.